Hi and welcome to today's video. Today I'm going to talk a little bit about the environment. Yeah, that's right, the environment. I know we talk about 3D printing, but today I'm going to talk about environmental impact of 3D printing. I know nobody else talks about this because 3D printing uses quite a lot of energy and it uses materials that aren't widely recycled and all of this stuff, but I hope to change that today. I've been sent some samples of material and some spools of material from a company called Filament. Now, I had to print out the brochure, so I'm going to hold it up here. There's the details. I don't know if you can see them. There's the address and the website. Definitely check this place out. And they have sent me some really awesome material. They can do kind of all sorts of materials. Check out that brochure. But the ones I want to talk about today are PLA. And I mean, I know I don't print in PLA. I tend to print in ABS and NinjaFlex, of course, because why not? But today I want to talk about PLA because Filament do recycled PLA. And that means that the PLA they make, 90% of it is already recycled from other PLA products. So before you've started, you've already helped the environment by using this material to use up some other PLA that's been recycled into this, which is pretty incredible. Now, I'm going to hold up the brochure here. If you want to pause the video, you can do. I'll try and move it up slowly, so if you want to read it, you can. The brochure page comes with pretty much everything you need to know about printing this material, from the printing temperature to the melting point to whether you need a heated bed or not and stuff. And the colours, I don't have a colour printer unfortunately, but the colours it's available in, there's quite a few, how tough it is, what sizes it's available in, etc, etc. Now, I have done some prints with this stuff. I got sent a couple of sample spools and I've messed about with it a bit. And they also sent me another material which I've never used before, and that is called PETG. And it's a polythene I'm not going to say that word because I can't, but it's a polythene material, and this one is also recycled. So here's the page of that one. I'll try and hold it as still as I can. If you want to pause the video and read it, hopefully you could see something there. And what it says about this one is it's made from recycled PET sources such as plastic bottles. So every time you have a bottle of water and you chuck that bottle into the recycle bin, it gets made into this material, or some of it does, or you know what I mean. So that's another thing. It's really strong stuff and it doesn't warp. So what I'm going to do, over the last few weeks I've been messing about with this stuff, and what I'm going to do, I'm going to show you how it comes in 1 kilogram spools, and then I'm going to show you some prints. I'm going to do the same part on the same printer with both materials, so you can see how different it is or how awesome it is, because let's face it, this stuff is awesome. It's recycled, it's really easy to use, it's awesome. So anyway, if you put an order in through filament.com, you'll get this, which is a white cardboard box with a label on the front that says Filament. Now, when this turned up, it was vacuum packed, it had the cellophane on it, and it was all kind of like airtight and stuff. So we open the box. Just ditch that for a sec. And as you can see, you've got a nice spool. It's got a pretty big hole in the centre, and I'll tell you what I'll do. I'll just quickly use this ruler here to measure. That is about 50 millimeters. And if you're in inches, it's bigger than 2 inches. Just. So it'll fit on most spool holders. It's a pretty nice spool, and it even has, a label on it. See if you can see that, of what it is. This one is recycled PET in apple green. Nice colour, I like it. And as you can see, it's also vacuum sealed. And can you see the silica gel to keep the moisture level down? Pretty cool. That's really nice. The packaging's really been thought out well. I like it. I'll show you the other one. This also came in, you know, vacuum sealed. You like this one? It's orange. There you go. It's exactly the same. It's all vacuum sealed in. It's got Can you see it? Oh, there it is. It's got silica gel in there to keep the moisture down, and it's got a sticker on the front to tell you what it is again. So, what I'll do is I'm going to load these onto the eBay printer. That's this one, because that's my worst printer. And you might think, why are you going to print this on your worst printer? Surely you want to print it on your best printer. No, I want to print this on my worst printer because I want to give it the hardest time I can. I want to make sure this material works for what it does. You know, I'm going to put it on my worst printer. I'm going to really torture it and see what's going to happen. So what I'll do is I'll set the printer up with the PLA, and I'm not going to video the entire print as like a time lapse or anything. What I am going to do is I'm going to show the important bits. So I'm going to show the first layer, because if the first layer doesn't look good, as we all know, you're not going to get very far. I want to show the top layers, because the top layers should be nice and flat and smooth. And then I'll also show a shot of the screen so you can see what settings I'm using on the hot end and on the heated bed. One thing I do need to say is that, yes, this is my worst printer. It is my experimental printer, and it does have an E3D Titan extruder and an E3D V6 hot end fitted to it. Now, the reason I've done that on that printer is because I need an all metal hot end on my experimental printer. But if it's under 240 degrees for the hot end, you don't need all metal. But these tests are all going to be with the E3D Titan extruder and the E3D V6 hot end. So let's cut to that now and see what it turns out like. So what I'll do now is I'll just give you a little bit of information about the printer settings used and the setup. So as you can see, it's printing on glue stick, which is applied to the glass. The bed is running at 40 degrees and the hot end at 215. The layer height is 0.2 millimeters, with the first layer being 0.3, and the first layer is over extruded to 200% to give you a good adhesion to the glass. Not that this stuff has any problem sticking to the glass at all. The external perimeters are running at 70% of normal speed, and the first layer runs at 20% of normal speed, and the nominal speed is 30 millimeters a second. This eBay printer it doesn't respond well to going any faster than that, so I'm trying to use this to give it the best possible chance it has of printing. So I'll just shut up while this finishes and we can continue. Well, what did you think of that? I thought that looked pretty nice. The first layer went down pretty nicely, and the infill in the top layers looked pretty flat. Just in case you're wondering, the part is a rotor arm for a quadcopter. The frame's on Thingiverse. It's a Pion 230. I'll put a link to the description in the file. But you want to see this print, don't you? Okay, here it is. What I'll do is I'll try and keep it and get it as best I can. That was the surface that was in touch with the glass. Hopefully you can see the layers with a bit of luck. I'll try and move it around as much as I can so that you've got a good chance to see the exact quality of this thing. It is just absolutely fantastic. I love this material. It makes you feel good until you drop it on the floor. It makes you feel good that it's recycled. It's made from recycled stuff. It can be recycled. It can be something else. You know, it doesn't take a lot of energy to print it. You saw the settings. The bed was at 40 degrees. That doesn't take much energy to keep that temperature there at all. It's really nice stuff. So let's see what the Pet G looks like. Well, that was the Pet G print. That looked awesome also. I love that material. It's really easy to print out. If I've got to say anything, I probably printed it a little too hot. 215 and 40 for the glass. I used exactly the same profile. In fact, I used exactly the same G code as I did for the PLA part. And it might be running a little bit hot. But you want to see it? I know. Here it is. So there's the side. Hopefully the camera can pick up the layers for you. That was the bit that was in contact with the glass. I'll try and move it around. It's not the best light in here. And the top surface, of course, everybody wants to see the top surface. And you want to see how flat it is. It's absolutely fabulous, this stuff. I absolutely love it. I'm definitely going to start using this Pet G instead of ABS because it's just so much easier to print. You don't have to get the glass really hot, you know, it prints at 40, it sticks to glue stick, and it's really nice stuff. So that's it. That is all I've got to show you. These two materials are fantastic in my opinion. I don't think I'll ever be replacing the ABS that I've got. Once it's run out, I'll just move straight over to this PLA and to this Pet G. I've got to give a huge thank you to Filament for sending us this stuff and giving us the chance to play with it. And, you know, it's really nice stuff. For stuff to be recyclable and recycled and to print so well, absolutely fabulous. Absolutely fabulous. I mean, I deliberately put it on the eBay printer because it's the cheapest printer I've got. It's got the E3D Titan extruder and the V6 hot end, all metal hot end in it, and that's the kind of that's the kind of finish you get on it. So, what's it going to do if you put it in a better printer? You know what I mean? It's going to be phenomenal, absolutely phenomenal. But like I say, huge thank you to Filament for sending me this stuff. Huge thank you. It's absolutely brilliant stuff. I absolutely love it. So, as usual, please like, comment, and subscribe. I've been Steve. Thanks for listening.